Let's look at quality and productivity. More specifically, let's look at quality and how it affects productivity. First, we're going to measure yield. So yield is the total number of inputs, and this is the total number of units started in a process. That number is going to be multiplied times the percentage good units. Now this is the percentage of units that come out of the initial process that meet quality specifications. Then we're going to take those products that did not meet quality specifications, and we're going to multiply that times the percentage of those products that did not meet quality specifications that can be reworked. And both of these percentages are averages over time that you will be provided. This is the equation. Yield equals inputs times percentage good plus input times 1 minus the percentage good times the percentage of products that can be reworked. Again, Y is total yield, I is the initial quantity started in production, percentage G is a percentage of good units produced in the initial run, percentage R is a percentage of defective units that are successfully reworked and meet quality specifications. Widget X produces widgets, obviously, and we start with a batch of 500 widgets. On the initial run, 85% of the widgets come out and they meet quality specifications. Of the remaining 15% that do not meet quality specifications out of the initial run, 60% of those can be reworked. Again, this is our equation. We'll plug our numbers in. So we start off with 500 units. 85% of those units come through and they meet quality specifications. And then out of those 500 units, there's a 15% that come out that do not meet quality specifications. And that is multiplied times the 0.6, which is the percentage of defective widgets that can be reworked. The initial run produces 425 units, with 75 units bad. The number of units that are actually reworked, or that can be reworked to meet quality specifications, is 45. So we add these two together, the 425 plus the 45, and that gives us a total of 470 units that meet quality specifications. What happens if we increase our percentage good from the initial run to 90%, which is only 5%? Again, we'll take our initial input, our starting batch of 500 widgets, we'll multiply that times the 0.9, and then we'll add in the widgets that were able to be reworked. In this case, our initial run produces 450 widgets, and the number of widgets that can be reworked is 30. That gives us a total of 480 units. That were able to be reworked and produced and meet quality specifications. Now, how do these numbers affect our cost per unit? This is our equation for cost per unit, K sub D, which is going to be our direct manufacturing cost per unit. Now, this is multiplied times our input. So if we start off with 500 units, our K sub D is going to be multiplied times 500. K sub R is going to be the cost to rework those units, or rework the units that did not come through the process the first time and meet quality specifications. R is going to be the number of reworked units. Y is going to be our yield. Let's use our previous example. We had 500 units that initially came into the process. Our direct cost is $25. Our rework cost is $10. Again, our percentage good on the initial problem was 85%, which resulted in 425 units. And our percentage of reworks, which was 60, resulted in 45 units. And our final yield was 470 units. So we're going to take our $25, multiply that times our inputs, and then we're going to add in the $10 rework cost to the 45 units that we're able to be reworked. We will take the sum of those and divide it by the total yield, which is 470, and we get a cost of $27.55 per widget. Again, what happens if we increase our percentage good up to 90% for the initial run? We get the $25 again times the 500 initial input, and this time we get the $10 times 30, which lowers our rework cost. Notice that our input cost is the same, $12,500. But this time, instead of dividing by 470, we're dividing by 480. We have a lower cost and a higher output, which results in a lower cost per widget. We are now at $26.67 per widget. So a lot of products end up having to go through multiple stages of production. We have yield equals the initial input times the percentage good that comes out of stage 1, the percentage good that comes out of stage 2, and so on, all the way to end stages. Again, the I is the input, and the G sub I is the percentage good that comes out at each stage. Do an example. This is a 4-stage process. The percentage good that comes out of stage 1 is 94%, or 0.94. Stage 2 is 96%. Stage 3 is 95%. Stage 4 is 90%. So this is our equation with the numbers plugged in. So our yield would be equal to our initial input times the percentage at stage 1, the percentage at stage 2, the percentage at stage 3, and the percentage at stage 4. Let's just multiply the percentages at each stage and see what we get. Again, we have our initial input, and then in the end, only 77.16% of the product that starts actually makes it out and meets our quality standard. So in this case, we will have a yield of 385.8 units, or 385 units, because you can't have a partial unit. Else comes to you and says, we're not yielding 500 units a day, but we're starting with 500 units. How do we yield 500 units? That would be your initial batch size. So let's look at an example. So we're going to start off again with the desired yield of 500, not the initial input. And then we're going to have the same percentages good at each stage that we had in the previous example. And our initial batch size is going to be equal to I. That is our unknown. This is the equation for calculating the initial batch size with the desired yield. So the equation is I equals the desired yield divided by the percentage good for stage 1, the percentage good for stage 2, all the way out to the percentage good for stage N. Let's look at our example. Our desired yield is 500. This is what your boss has requested. And again, we know at each stage, 100% does not come through meeting quality standards. So we take our percentage good from each stage, put it in the denominator, multiply them together, and we end up with 0.7716. And then we divide our desired yield by the 0.7716, and then we get 648 units. So this is the initial batch size that we need for our desired yield of 500. So to produce 500 units at the end of the day, we must start off with 648 units.